See where your kilowatts is going, consumption is, very simple power logger. If you want to do troubleshooting, right, harmonics and unbalance and all these things, you're going to do a really extensive power quality troubleshooting, this is not the tool for you. We have another one, but this is a very simple energy logger. It quantifies energy consumption before and after improvements. So before you do any action, you take a measurement, make some measurements, and after you have, let's say, changed, so let's say you've changed all the bulbs in this room to energy saving bulbs, you take another measurement to see the before and after. It's a very good tool for that purpose. Energy waste logger functions, it will measure and give you the kilowatt hours. It will tell you the harmonics, how much harmonics you have, what is the unbalance that you have in your system, what is the power factor, and what is your peak demand as well. Because what the meter does is you can set a sampling averaging of 15 minutes, and let's say you do a measurement for a month. When you export it to your software, you just put the cursor at the maximum point, and that becomes your peak demand. That's when the maximum demand I've had. It's very easy to use. It's a powerful tool and complete. It comes with 4 sets of CTs. These are 30 amps and 3000 amp ranges. And they don't need a separate battery, which is very useful because if you're doing the logging for 30 days, most of the competition models in the market will sell you a CT and they have a little box with a battery there. They'll put a 9-volt battery. If that battery runs out during your measurement, what good is it, right? So this is, the clamps are being fed from the unit itself. So it's a very powerful unit that way. It does come with the software. Fluke does not want to pay you or charge you extra for software, sorry. We give it free of cost with the unit. And in fact, the software is free that you can even go to the Fluke website today and download it free of cost. It comes with sample reports, so you can physically see how this software is looking like. View the graphs, generate reports with the software, and most important, Faiz mentioned that in the first slide about Fluke, safety. 600 volt, category 3 rated, okay? Category 3 is power distribution loads. This is where all you guys are working today, in a Cat 3 installation. Does anybody know what this Cat 3 means? Has anybody heard of this category terms before? Show of hands. Because I can give you a quick crash course on what category is. No? Okay, so what is a category? If you look at an installation, okay, this hotel, for instance, if I probably go to the basement, I will find the main incoming, right? Where the power is coming in. Cables are coming into the main TV. That area, which is what we call the service entrance, is what we call the category 4 area. That is the area where if you have a fault, the energy produced is really the worst. It's very high. Cause this whole building to catch fire, or in fact, you'll have loss of life, okay? And when the power comes in, goes to the loads, let's say the branching circuit, so fixed loads like elevators and motors, the connections there, that's a category 3 area, where you also have a problem. And then it branches down to, let's say, sockets, like electrical sockets, receptacles, all these plug points. These are category 2 installation. And then if I open up my laptop and I work on the printed circuit board, that's a category 1 installation. Where I can have a fault. I can have a spark or whatever, but the energy produced is not high enough that it might, let's say, kill you. It might cause you a burn. It doesn't kill you really, okay? So the point is, if you are working on a category 2 area, you have to use either a category 2 instrument or higher, never one that's below. Because if you use a category 1 tool on a category 2 area, that category 1 meter is not going to protect you if you have a fault in that category 2 area. So who decides these caps? The IEC. The IEC tells if you're working in such an environment, the tool that you use must be certified to this category. But the problem is, the IEC does not go to every company, like Fluke, like Megger, like Greenlee, like whatever company you have, and they don't actually check if Fluke is making Cat 4 meters. Are you making Cat 4? No. They just say the standards. It's up to the manufacturer to verify, to claim, and to prove that we are reliable to Cat 4. Okay? So how does Fluke do it? If you look at all our multimeters, and even some of our things like scope meters, oscilloscopes, and oscilloscopes is a good example. These are category 4. So who verifies that these are category 4? Number one, Fluke makes the claim, saying yes, we are category 4. But if you look on the back, on the labeling, you will see that this meter has been tested by more than 2 laboratories in the world, like CSA, TUV, VDE. These are standard bodies, laboratories that test and verify, yes, this meter is category 4. Okay? So just to give you a little example, an example of a category 4 meter. A category 4 meter must withstand a transient voltage of 8,000 volts. 8 times on the positive cycle, 8 times on the negative cycle. That's the requirement. 8 times, I'm going to give impulses of 8 kilovolts. And the meter must survive. Not even break, fuse is intact, everything is okay. That's the requirement of category 4. And that's what IEC says. Fluke, we go a step further. We make sure that we don't just comply to this 8 kilovolts, but we give you a little bit more extra margin. So if you look at some of our multimeters, in fact most of our multimeters, they will fail at 18 kilovolts, which is much, much higher than what the standard says. So 18 kilovolts will give you that extra warranty, extra peace of mind when you make the measurement. So as electrical engineers, when we go make measurements, you are dealing with live power, very dangerous situations there. You want to make sure that you are using the right tool for the right area. Okay? So the next time you buy a multimeter, thinking, okay, Fluke's expensive, there's a reason why we're expensive, because we give you quality, we value your life. And if you don't think that's an important price to pay, you are free to buy a meter that's costing you 10, 20 dirhams. No, I'm not kidding. You can find multimeters for 20 dirhams if you go to AS Hardware. But they will not protect you in the category 3 environment. Okay? So that's the Fluke 1735. This is a very nice tool for power and energy logging. Logging of these parameters that will help you to identify and quantify the electrical energy waste. So energy options, again, if you look at a sample energy log, this is just a picture we have from for different dates, different months of the year, okay? So every month we look at energy consumption, and you can see for a certain amount, let's say in July, we've really peaked the higher. And this is sort of, I would say, replicable in this part of the world, because in this part of the world, I think the peak demands in summer. Summer because everybody is using HVAC. Air conditioning is fully on, so you would expect to have a much higher energy curve there. Compare the operating schedule against utility rate schedule. So how much your factory is operating, and now for me, I'm not sure how Viva is actually charging big companies. I don't know if it's similar to what they're doing for houses. I think they have a different billing cycle. Maybe you guys can tell me if that's different. But from what I know, it has to be slightly different from how they charge houses. Change operations to take advantage of lower cost energy times a day. Sometimes they will charge you lesser amount of money from a certain time, let's say from 12 midnight to 6 a.m. If they're doing that, then you should take advantage of those times. Times when machinery can be turned off. When can I switch off the HVAC units? Not needed, etc. Sensors and controls that could enable systems to be turned on and off. Motion control, automation systems, etc. Set up infrastructure, equipment startup, shutdown schedules for occupied versus unoccupied modes. Looking at startup stage equipments with large electrical power consumption, you gap it by 15 minutes, to avoid peak demand charges, so between repetitive instruments. Installing VFDs, a lot of people are doing that. From soft starters, they're going to VFDs for big motors, And you definitely want to replace all your existing bad motors with a high efficiency motor. Okay? So looking at these options, it's a good place to start. We know exactly where to look at energy options. But you can also get started with a thermal scan. So we spoke about power quality, but again, that manifestation into temperature is a very good indication. Okay? Temperature is a nice thing. It's a unique physical quantity because temperature is the second most measured quantity in the world, next to time. Time is the first most. But temperature is the second most measured quantity, right? If you have coffee in the morning, you want to make sure the coffee is hot. When you get up in the morning, you have a shower, check the water temperature. Oh, it's too hot, too cold. In the car, in the room, temperature is measured everywhere. And it's a very good indication of a problem. So with the thermal scan, in switchgear, you want to measure temperature because that power anomalies will manifest as temperature. In panel or in the 230, 480 panels and loads, again, temperature rise because of harmonics. If you know harmonics, harmonics is manifested as heat. It's extra current, right? It's added energy, and it's heat. So if you look at thermal imaging, why is it so important? And let's talk about heat waves by electrical systems. So this is the basics about heat transfer. Heat transfer is again happening in three methods. It happens as conduction, it happens as convection, and it happens as radiation. If you look at solar energy, right? If you step outside the building, you immediately feel the heat of the sun, right? Yes, no? Yes, and that's radiation. That's happening everywhere. Even in this room, I have radiation. My body is radiating energy. And I'm sure if you have one person standing here, and then I bring in 1,000 people, what's going to happen to the temperature? It's going to change, because all these people are radiating energy, right? It will change the situation. Conduction usually happens between solids. So when you cook food on a frying pan, the heat is transferred from the frying pan to the meat, whatever, through conduction, solid to solid. Convection, in this room, forced cooling. The wind is cooling us down. This is convection. It usually happens. So all objects will emit infrared radiation. Thermal imaging cameras are looking at this infrared radiation. They are measuring that infrared radiation, and they convert that radiation into data that you can work with. Okay? Key point to note is that we are only measuring surface temperatures. A lot of people still have the misconception that a thermal camera can look through doors. It's not possible. Thermal imaging is it's one of the biggest disadvantages of thermal imaging, is the fact that we can't look behind closed enclosures. So if you're looking at cables, motor terminations and so forth, you need to get those covers open, because if it's not open, you're not going to see the condition of the panels inside. Electrical objects emit heat as a byproduct. Too much of heat or a change in the amount of heat indicates an inefficiency. And that's what we want to measure. So, measurement theory, the electrical heat, or what we call the delta T, the difference in temperatures, typical reasons for electrical hotspots. Harmonics is a very good indication, because harmonics is extra energy that's always added, and extra energy means extra I squared R, which is extra heat. And that's what you see it on cabling. If you have too much harmonics, especially third harmonics. Third harmonic is such that it always adds up on the neutral feeder. So when you make a measurement, and if you're finding the neutral conductor to be, you get very strange current readings on the neutral, that's definite 100% third harmonic. So with thermal imaging, I make a measurement on my cabling, and I see the neutral feeder extremely warm, warmer than the phases, which should not happen. That's a sign telling me, hey, I've got a lot of third harmonics there. Unbalanced loads, also a very common cause of electrical increase. Overloaded systems, too much current, again, remember the formula, I squared R. Too much current, more heat. Loose or corroded connections. If the connections are loose, corrosion, rusting is eating away the connections, you are changing contact resistance. If contact resistance changes, the power will change. And that's why an instrument like insulation testing is a part of predictive maintenance, because people measure insulation of cables, but also things like low resistance ohm meters are used to measure the contact resistance as well. Insulation failure. PVC cabling, if the insulation is failing, you've got problems there. Wiring mistakes, component failures, and of course you have under-specified components like fuses. A classic example is in your own multimeter. I used to be in service before I did this work, and I used to always get meters for repair. I would open them up, and what would I find is very shocking. Instead of the fuse, and if you've seen the fuses on a Fluke multimeter, they're about this big, thick ones, high energy fuses, right? What I usually find is, I find the fuse, right? And the customer says, I'm not able to measure the amps. I look at the fuse is okay, and I take it out, I look at the back, there's a little piece of wire that's stuck there, right? Because the customer blew the fuse up, he didn't have the patience and the time to wait to call the agent to send a replacement fuse. He wanted to get his job done, so he did the next best thing. He's just made a contact with the wire. That wire is under-specified. It's not going to help you if you have an overload condition, right? Those fuses are meant for your protection. If you have a broken fuse, rather than putting aluminum foil or cigarette foil or a piece of copper wire, it's best to leave it open. It'll at least protect your life, okay? So under-specified components is a problem, and you want to make sure that you look at that. So when it comes to measuring, so what can I measure? What can I inspect in electrical equipment? Three-phase distribution boxes, capacitors, circuit breakers, transformers, switches, cables and lugs, insulators, relays, UPSs, everything. In the electrical world, almost everything can be measured. Battery banks, again, so if you have data centers, and I'm sure a lot of you are from data centers, battery banks, important, right? For a data center, that's the critical equipment. Like in an industry, a motor can be a critical equipment. In data centers, I think UPSs are critical. Because if you lose data, boy, you're in big trouble, right? For a bank, they don't want to be losing the data, because then people like us will lose our money, because the bank's lost its data. So you want to make sure that you measure and inspect these components on a regular basis. So Fluke thermal images, we do have quite a selection within our range. I think we have about, if I'm not mistaken, 7 plus 3, 12 models to choose from, depending on the price and application, of course. But if you look at our thermal imaging, we started thermal imaging in 2004. That's when we first introduced thermal imaging into the Fluke side. And we're not the only ones in the market, right? There's other companies that are also selling thermal imaging cameras, but we do have a clear winning advantage when it comes to our thermal imaging cameras. And those are the fact that, like I said before, for the last 65 years, we've been making tools for the industry. We know exactly what engineers want in the field, because you might be working in a harsh environment. So IP rating is important. You might drop your tools. I know I drop my mobile every now and then, right? And it survived so good. 6.5 foot drop, or a 2 meter drop. It does survive. And I tell this to customers and say, okay, so that's good. So if I drop it on a daily basis, I won't break it. I'm saying if you're dropping it on a daily basis, then you've got some problems with your hands. Because saying the fact that it can be dropped 2 meters doesn't mean that you every day drop it 2 meters and test the camera. If you drop it every day, you will eventually break it. Okay? Accidental drops. Drops 2 meters, it's fine, you pick it up and you use it. It combines the power of infrared images with visual light images. I'll show you some pictures of that, but here you can see the thermal image, but you can also see a visual image on top of that, because that helps you to understand what's behind the thermal picture. Okay? A lot of people are not experts in thermal imaging, so to have a reference is always important, so you know what you're talking about. Delivers clear, crisp images to find problems very fast. multiple measurement capabilities, IR OptiFlex. Focusing is automatic. Half the time when you buy thermal cameras, you go into the field. If you're a professional thermographer, myself, Faiz, and Zaina, we're level 1 thermographers, we can take any camera and we can focus. Easy, because we've learned that. A lot of new people, if you're buying a thermal camera for the first time, and you have no idea how it works, you need to focus to get a good picture. Because if you don't get a good picture, you don't get good temperature, and then your readings are all wrong. So what we've done with our new cameras is we've got automatic focus and manual focus. The best of both worlds. You just take the camera out of the box, switch it on, and you use it without having the need to focus. So it's focus free as well. And as always, Smart View software. We provide the software license free and at no extra cost. You can again download the software from the Fluke website. It comes with sample pictures. You can make your own reports, completely license free. So upgrades to the camera and to the software are free for life, right? Again, going back to what Mr. John Fluke said, servicing the product. We always feel that the customer, you guys should get more than what you paid for, and it's much more than what's shown here. There's a lot more features, of course, but things like free software is very, very good. So we've got the TI 100 series, which are these cameras. They are very light. They weigh, I don't remember now, it's something like 700 grams. Very light in your hand. Extremely rugged with the 2-meter drop and easy to use. And we have the P3 series. 3 Ps, proven, practical, high performance. These are for the advanced thermographers, people that want the really high definition picture, good sensitivity. And then we have the TI series, which is rugged tools for everyday use, for very general purpose, so forth. Okay, so we do have a lot of cameras. In fact, we do have both the P3 series here and the TI series as well. So you can have a play with it during the coffee break. So, following up with electrical measurements. Once you do a thermal image, so you find out harmonics, you find the neutral conductor hot, that's telling you you've got a problem with the harmonics. How do you verify that? You plug in your power quality meter to verify. What's the condition there? How much harmonics do I have? Do I have any over or unbalanced conditions? Power factor, kilowatts, all these can be measured. So it's sometimes a combination of more than one tool. Unfortunately, we would love to have, as maintenance engineers, we would love to have one tool that did everything for us, right? But it's not always possible. Sometimes you need different tools to do your work. Power factor penalties, again, just to show you what it is, but reactive power is wasted power. It does no useful work for us, so we want to make sure that you keep that reactive power very low, because it's wasted power. It does no useful work. Many utilities charge for every percentage point over the limit. So every 0.01 you go below 0.97, they will charge. Of course, again, check your utility rate plan. Now, I can't confirm, but I know in Saudi they do this. They do have a standard there. How does your utility measure power factor? Are they measuring? I think here you are just billed for kilowatt hours. You're not. They don't show you what your kilowatt or kVA are is, what your reactive power is. They just bill you for kilowatt hours. And that's the thing, because consumers don't understand, if I have reactive power, that's wasted power, right? What's essentially happening is now I'm buying more power from the utility to compensate for that reactive power. So utility is billing you for kilowatt hours, and as a consumer, you're just looking at kilowatt hours. But if you measure your reactive power, you know exactly how much is waste, so you can buy lesser. Okay, here we have a lot of natural resources, oil and gas, good. I don't think they're very conscious, but I know for a fact in countries like Jordan, where I just was last week, and the guys told me that for them it's very critical that they can save energy because they don't have natural resources, not as much as we have here. So countries like Jordan, where they're buying fuel to make power, if people use less power, they have to buy less fuel. Buying less fuel means they save money. So it's very, very important. So the example of calculation, if you assume that the utility is adding 1% demand charge for every 0.01 below the 0.97, and if your power factor is averaging 0.86 per month, your demand charge is $7,000 on a monthly basis. So again, if you look at the difference, times 100%, again times 12 months, you're looking at an annual cost of almost $10,000 just on wasted power factor. Just on reactive power, so that's a big cost. Now, you might not see this in your bill today, but it's an easy calculation to do. To do that, the only thing you need tools. To measure, to quantify, okay? So that's the 435 Power Quality Analyzer. This is an extended power quality tool that's used for diagnostic and troubleshooting work. It not only measures the power and energy, but it also helps you to troubleshoot your problems with harmonics, so you can troubleshoot real time. It has a logger function. There is a system monitoring function that will tell you how clean is the power that you get from the utility. So if you want to understand if the power supply coming into my building is clean, I need to do system monitor. It has an automatic transient mode that will automatically capture any high voltage switching that you experience within your measuring period. It's got power wave data capture, ideal for large motor startups and generator startups, and waveform capture.